Question number 7. The diagram shows the functions of f of x is equivalent to modulus of 2x plus 1. Find the value of m and n such that m must be bigger than n. So if you look at this one, they tell us that the f functions is going to receive the x as input, and this is how we're going to process the x. And we realize that m and n are going to give us the same answer. So let us write it down first. We can say that f of m is equals to 11 and f of n is equals to 11. So how do we write it down? We can say that now the x is no longer unknown, as we know the input is m. So we have 2m plus 1 is equal to 11. But don't forget, whenever we have an unknown inside the modulus, we always have two scenarios, either it's a positive or negative. So let's do for positive first. So we have 2m plus 1. Positive means that we're going to do something like this. This is a positive case. So 2m plus 1, the plus 1 go to right hand side, become minus 1. So we have 2m is equals to 10. M is 10 divided by 2 is 5. Meanwhile, we try to do for negative case. So negative means that we put negative in front. Then we do like usual linear equations. So negative 2m, negative 1 is equal to 11. Minus 1 go there, become plus 1. Then negative 2m is equivalent to 12. When they're together, it spend time together. So go there, become divide. So m is equals to negative 6. So it means that m can be 5 or m can be negative 6. How about we do for n now? But since we know they are exactly the same, just the alphabet is different, they must have the same result where n can be 5 and also can be negative 6. One more time again, why is it like this? Because we can see that they have the same result, same answer. If you don't believe me, you can substitute, you will have the same answer. But since they tell us that m must be bigger than n, so m must be equals to 5, n is smaller, must be negative 6. Then we are done. Question number 8 is given that the relation between set x and set y is defined as the following set of the order pair. So they give us the functions in terms of order pair. So we're going to try to translate this one to become more something we are more familiar with in terms of the arrow diagram. They say set x and y consists of this kind of numbers. We just need to plug it in 4 and 6. And we're going to have 2, 3, 4, 5. And how do they maps together? They give us when it's 4, they're going to be 2. 4 is going to 2. But 4 is also going to 4. Wow, one person will go to 2 persons. So it's like one to many functions. Next one, when it's 6, it goes to 2, but 6 also go to 3. 6 go to 2, but 6 also go to 3. They ask us to find the image of 6. So again, whatever the element in the x is called object, whatever the element in the y in the codomain is what we call as the image. So 6, we have 2 images, 2 and 3. So we can say that the answer is 2 and 3 because that is the image of 6. The range of the relations. So what is the range that we have here? We have 2, 3 and 4. Because we learned this one last time, you are in the range whenever you have the partner. Means that when somebody connected to you. And this one, the last one here is what we call as the, sorry, you are not in our range. You are out of range. Because why? Nobody connect to you. Out of the range. Question number 9. Given that fx is equal to x plus 3 and the composite function of the gf inverse is given by 7x minus 27. Find the g inverse functions. So how do we find the g inverse? Before that, we need to know first what is the original functions. Since they give us the g inverse of f is 7x minus 27. So if we want to get our gx, we just need to remove our f inverse, right? But how to remove? So the best way of doing this is by using a property of, just remember, whatever the original times the inverse functions, you will get back nothing, which is 1, something like the identity. So how do we mean is, already, let's say you have 2 times the inverse of 2 is 1 over 2. You will get back 1. No matter what is the number, as long as this is the property that we are using, you will get back 1. If you don't believe me, let's say with 99 times 1 over 99, we will get back 1. So same thing here. If we have f inverse x, want to get rid of this one, we times with fx. Then we bam, nothing, cancel out. We just get 1. So this is how we're going to do. We're going to plug in our x by the original function here, so that we have 7 fx minus 27. But what is our fx? We know. It's given at here. X plus 3. So we know that it's just x plus 3 is our fx. And we just need to expand. How do we expand? 7 times x, 7x. 7 times 3, 21. Minus 27. And we combine the like terms, we will have minus 6. So this is what we get our gx. Because we know f inverse here combined with f, we cancel out, become 1. So this is how we get our gx. So after we get our gx, what should we do? We just need to inverse. So let me erase everything here and pull this one up by a little bit. Okay, so now we want to find the g inverse. How to find inverse functions is very easy, right? We just need to do learn it yourself. So let y is equals to 7x minus 6. I means interchange, x become y become x. So we will have x is equal to 7y minus 6. Can you see that? Y become x become y. And the last step is just solve for y. So means that we are looking for this one. So what should we do is, we're going to move the minus 6, go to the left hand side, it will become x plus 6 is equals to 7y. So we want to find y. When you're together it's a times, you go over, become divide. So we will have x plus 6 divided by 7, which is y. But don't forget that this y is eventually our inverse of g functions. So that is our final answer. So we can just write down as g of inverse x is equivalent to x plus 6 over 7. And we are done. Question number 10. The diagram shows 4 functions and its graph. State the graph that represent a 1-to-1 relations. Give the reason for your answer. To prove that it's a 1-to-1 relations, we're going to carry out the horizontal test. Horizontal test, we make sure that every of the object have only one image and every of the image have only one object. So let us carry out now the horizontal test. So we try to do every of the horizontal line at a random place. So we can see that this one only have one intersection, so which is fine. This is a 1-to-1 relations. Can you see that? This one have 2 intersections. Oh no! So this is not a 1-to-1 relations. And this one is fine because I have only one intersection. And this one is even more worse. We have 4 intersections. So it's not a 1-to-1 relations. So we can conclude that it's only fx and hx. So we say that fx and hx. Because every object have only one image and every image have only one object. So next, we're going to look at question B. And this question asking for does not have an inverse. Give reason for your answer. So we know that for a function to have an inverse, it must be a 1-to-1 relations. So whoever is not 1-to-1 have no inverse. So we know that gx and kx is not one-to-one relations, so they doesn't have the inverse. So we can say that gx and kx have no inverse. So what is the reason? Because the image has multiple objects. Hey, if you have any questions or would like to see any kind of video, leave your comments below and let me know. If you want to support us so that we could make more videos like this, the simplest way is just by sharing the video with your friends. Click the like buttons and consider subscribe to this channel. See you in the next video.